Dear students, I am Dr. S.K. Tamrakar from Bhartiya College of Agriculture Engineering. I am teaching engineering mechanics, and our today's topic is related with the force, that polygon law. Polygon law of forces. This law is used to some number of forces. If number of forces are acting, concurrent forces are acting at a point like F1, F2, F3, F4, F4, F5, F5. If they are represented by the sides of polygon taken in order, then the resultant is the closing side. We can start with start with some forces. We start with F2 here, then F1. We have to take the forces in order, then F5, then F4, then F3, then this closing side is called resultant, and its direction is in opposite direction. So this is the polygon law of forces. Here the sides of this polygon is represented with these forces. Then the resultant is the last. This closing side is called the resultant. This is used to find out if number of forces are acting on any body. Then next is constraints. Next, constraints. Action and reaction. If here is any plane and a ball is here moving in any direction, then this have only one constraint. If this ball, first we assume this ball is here in the 3D, 3-dimensional point. This can be taken as ball. Then this ball can move this side, up, down, front, behind, any side, 3 dimension, this ball can move. And if this ball is put in a plane, if this plane is taken as horizontal plane, then this ball can move in this direction, or this direction, but this ball cannot go below this horizontal plane. So this is a constraint of the ball. That ball cannot go beyond this horizontal plane, below this horizontal plane. So these are the constraints. Then action and reaction. If we give force to any ball, then this ball will move in this direction. This is called action. If this ball is resting in a plane, in a horizontal plane, then this weight of this ball is acting downwards, and because of this some reaction from this horizontal plane is also there. That is called reaction R. If this point is A, then this reaction is called RA. Every support will give reaction to the body. Then next is types of support. Next is types of support. Types of supports. There are different types of supports like frictionless, support, where what we have discussed, a ball is moving on a plane, then this is the example of this frictionless support. Here, if friction is not there, this way ball act downwards and the reaction from the plane is upward. This is upward reaction. So this type of support is always there in each type of object. These are the frictionless support. Then next is roller and knife edge support. Roller and knife edge support. Knife edge support. Roller and knife edge support. If here is any rod and if at point this side A some roller support is there and at point B some knife edge support is there, in this time here some reaction RB from this side, because this beam cannot go downward, and this one is a roller support. This will also give a upward reaction at RA. Beyond this point, this roller, this rod cannot go downwards. This is the roller and knife edge support. This is knife edge support. Here this beam is supported on the knife edge at point A and B. Here reactions are RA and RB. So this beam cannot go downward in downward direction, and these are the reactions. Then next type of support is hinge support. Next type of support is hinge support. Hinge support. Here this rod is supported at one side knife edge and on other side this is supported on the hinge. This is point A hinge. So here two type of supports are there. One is RA in upward direction and another is in this direction. This is RAY, this is RAX. Practically this we can use here the resultant of this RAX and RAY in the direction. This is called RA, and here load is acting at this direction. So in this type of rod, if the supports are RA, Y and RAX, so the resultant is in RA direction and this point B is in upward direction. Here the resultant is RB in upward direction. This type of three supports are there. Either we can see supports, or we can say this RA with some direction and RB. Two type of supports are there with some direction, or we can find RAX in horizontal, RAY vertical and RBY vertical, because this type of loading is also inclined here, so this same type of support is used. Next is built-in support. Next type is built-in support. Built-in support. In built-in support, one side is embedded in the wall and other side having knife edge support. This is point A, this is point B. So here support is RB vertical. Here this support is also RA, and some movement is also there. Movement is also working there. This type of support is built-in support. Generally they are also called cantilever type of support. So in the built-in support, some X, this type of one force is also there, RAY and RAX, this type of support. Maybe this is more than hinge support. Hinge is having one horizontal and vertical. Here one movement is also there in the built-in type support. Yes, let's have a numerical for finding out the resultant of these two forces acting at a point. One force P is acting at an angle 15 degree and one more force Q is acting 100 Newton at an angle 30 degree from this P force. For finding out the resultant, we have to resolve these two forces in X and Y coordinate, that is in rectangular resolution. So the Fx equal to F1 and Fx1 plus Fx2, that is equal to, resolving this, P 950. So this component is Fx1, that is P cos theta, that is 50 cos 15. This is 50 cos 15 plus, resolving this Q force in this horizontal direction. This angle is 30, this angle is 15. So here this angle is 45 degree. So for this we have to find out this component as 100 cos 45. So this one is 100 cos 45 by putting the values of 50 into 0.5, 0.259, 0.259 plus 100 into value of cos 45 is 0.707. So this Fx, this is summation of Fx, sorry. This is summation of Fx. This value comes 119 Newton. This is 0.996. 0.996. So this value comes 119 Newton. 119 Newton. Now finding out the summation of Fy, that is equal to Fy1 plus Fy2. These are 50 sine 15. 50 sine 15 plus this 100 sine 45. 100 sine 45. So this value comes 50 into 0.50 into 0.259 plus 100 into 0.707. So this value of Fy comes 83.64 Newton. Now finding out the resultant. This resultant equal to square root summation of Fx square plus summation of Fy square. So this comes 119 square plus 83.64 square as square root of this. So this value of R resultant comes 145.46 145.46 Newton. This is the resultant of this. And finding out the angle, the formula is tan theta equal to summation of Fy by summation of Fx. This comes 83.64 that divided by 119. So the value of theta, that is tan inverse, this value of theta comes 35.10 degree. The value of theta 35.10 degree. So we can also show this at an angle of 35. This one is the resultant equal to 145.46 Newton at an angle of 35.10 degree. ऐसे ही हमको और भी क्वेश्चंस सॉल्व करने हैं. नेक्स्ट इज if anyone having any problem by solving this type of question, you may ask. Next topic is equilibrium. Next topic is equilibrium. Equilibrium. If any body is like this and number of forces are acting on that body, number of forces are acting on that body, and what is the resultant at that time? If the resultant comes 0, then this body is in equilibrium, where the resultant of all these forces is equal to 0. If these are F1, F2, F3, F4, F5, F6, these number of forces are acting, then the resultant is 0. That is the summation of Fx equal to 0, summation of Fy equal to 0, and this resultant is equal to 0. At that condition, the body is in equilibrium. So for the equilibrium, this forces Fx summation